Hello students, so we are doing laws of indices from exercise 7b. So in our previous videos, we have already completed till question number 4 and today we'll start from question number 5 onward. Okay, so let's begin. So this is question number 5 from exercise 7b. We are asked to find the values of m and n and we are provided with this equation, isn't it? This equals to this equals to this. 4 to the power 2m equals to cube root of 16 to the power minus 6 upon n equals to root 8 square. Okay, suppose this is a equals to this is b equals to this is c. If a is equal to b and b is equal to c, then you can write a is equal to c and b equal to c, isn't it? If a, b and c all are equals, then you can write a equals to c and b equals to c. Okay, same thing we are going to do here. Okay, this means first case. Okay, first what we do is we write 4 to the power 2m equals to root 18 squared. Okay, root 8 squared. Okay, root not 18, root 8 squared. Okay, now if we have root a square, we can write root a into root a, isn't it? Root a into root a means root a into a. Now we make the pair of this a and take out of the root. Okay, we make this a root free number. Root under a into a means a. Okay, this square root is freed from this a now because we make pair of 2. Are you getting me? So if we write root m square, we can write m straight away. If we have root 5 squared, then we can write 5. The same principle applies here also. Root 5 squared means root under 5 into root under 5. This means root under 5 into 5, which means 5 we make a pair and remove the root. Okay, this means 5. Root 5 squared means 5. I hope you got this. Now since we have root 8 square, this can be written as 8, isn't it? So or 4 can be written as 2 to the power 2. Okay, 2 squared is 4, 2 multiplied 2 is 4, 2 multiplied with 2 gives us 4. So 2 into 2 means 2 squared. Okay, 2 squared is 4 and this 2m, here we write 2m, isn't it? 2 squared is 4 and this power 2m we write as it is, equals to root 8 squared means 8. Okay, or 2 to the power 2 into 2 4m equals to 8 means 2 cubed, isn't it? 8 means 2 4s are 8, 2 2s are 4. 2 multiplied 3 times gives us 8. 2 cubed is 8. Now we have the base same 2 and 2. If the bases are equal, then their powers will be also equal. Or you can write 4 to the power 4m equals to 3, isn't it? Or m equals to this 3 comes here and this 4 goes to the denominator. Cross multiplication. So the value of m is 3 upon 4. Okay, so this is a proper fraction, isn't it? The number in the denominator is greater than the number in the numerator. Now we will find the value of n as well. Okay, so this number cube root of 16 whole to the power minus 6 by n equals to root 8 squared, isn't it? So this can be written as root a can be written as a to the power 1 by 2. So cube root of a can be written as a to the power 1 by 3, isn't it? Fourth root of a can be written as a to the power 1 by 4. These are the rules of indices, isn't it? So cube root of 16 means 16 to the power 1 by 3. Okay, cube root of 16 means 16 to the power 1 by 3 into minus 6 by n. Okay, equals to root 8 squared means 8. Now this 3 1s are 3, 3 2s are 6, or 16 means 2 to the power 4, isn't it? 16 means 2 8s are 16, 2 4s are 8, 2 2s are 4. 2 multiplied 4 times gives us 16, so 2 to the power 4. Okay, now into 1 into minus 2 is minus 2. Okay, and in the denominator we have n equals to 8 means 2 cubed. 2 multiplied 3 times gives us 8. 2 cubed is 8, isn't it? So, or since their bases are equal, 2 and 2 base are equal, their powers will be equal. So 4 2s are 8 minus 8, 4 2s are 8 minus 8 by n is in the denominator, equals to 3, or minus 8, let us bring this 3 to the denominator here, 3 equals to, and we take to the numerator by cross multiplication. Okay, n goes to the numerator, 3 comes down to the denominator, so n equals to minus 8 upon 3, or n equals to minus 8 upon 3. So this is the value of n and this is the value of m. Okay, I hope you got this. Now let's do another question. Okay, now let us do question number 6. So we are provided with these two equations. Okay, one is this and another is this, and we are asked to find the value of x and y. There are two variable terms, one is x and another is y, so we need two equations and two equations are given to us. Okay, let's first make this equation simple and then we solve this equation by the method of elimination. Okay, simultaneous equation by the method of elimination. Okay, now we have root 32x, which means you can write this as 32 to the power 1 by 2, isn't it? Root a means a to the power 1 by 2, isn't it? Root a means a to the power 1 by 2. So root 32 means 32 to the power 1 by 2. Okay, so into x divided by 2 to the power y plus 1 equals to 1, or 32 means 2 to the power 5, isn't it? 2 to the power 5 into x into 1, x by 2, 2 is in the denominator, okay, 5 is in the numerator. Now divided by 2 to the power y plus 1 equals to 1. Now, or 2 to the power 5 into x, 5x by 2, 2 to the power 5 into x, 5 is in the numerator, so 5 into x, 5x upon 2 divided by 2 to the power y plus 1 equals to 1. 1 means 2 to the power 0. Okay, because if I write a to the power 0, this means 1. Any number raised to power 0 is always 1, isn't it? But 0 to the power 0 is not 1. Okay, 0 to the power 0 is not 1. Apart from this number, any number raised to power 0 is always 1. This means instead of 1 I can write 2 to the power 0. 2 to the power 0 means 1. Okay, or here you can see the same base. So if a to the power m divided by a to the power n, then what we write is a to the power m minus n. If the bases are same and there is a division sign in between them, then their power should be subtracted. A to the power m divided by a to the power n is written as a to the power m minus n, isn't it? The same thing. This is open, this is divide. Okay, now we have the same base 2 and 2, so their power should be subtracted. So 2 to the power 5x by 2 minus y plus 1 upon 1, okay, equals to 2 to the power 0. Now you can see 2 and 2 same base 2 and 2. This means their power should be equal, or you can write 5x by 2 minus y plus 1 by 1 equals to 0, isn't it? Let me continue this here. Now let us take the LCM of 2 and 1. The LCM will be 2. 2 1s are 2. LCM will be 2, isn't it? So 2 when multiplied with 1 gives us this 2. That means 1 into 5x. 5x minus, this minus comes here, 1 into 2 gives us this 2, so that 2 into y plus 1, 2 into y plus 1, okay, equals to 0. Equals to 0 is in the right hand side. Or we simplify this, 5x minus, minus into plus, there is no sign in front of y means we should understand there is plus sign, minus into plus is minus, 2 into y is 2y, minus into plus is minus, 2 into 1 is 2. 2 into 0, we cross multiply this, 2 into 0, when we multiply any number with 0, we get 0, isn't it? 0 into anything is always 0, so 2 into 0 is 0. Or 5x minus 2y equals to, minus 2 we take to the right hand side, becomes plus 2. This is equation 1, okay? 5x minus 2y equals to 2, this is equation 1. Let me copy this equation here, we need it later on. 5x minus 2y equals to 2, this is equation 1. 5x minus 2y equals to 2, okay? Now I'll erase this and make equation 2 also simple, okay? So we have 8 to the power y, or 8 to the power y minus 16 to the power 4 minus x by 2, 4 minus x upon 2 equals to 0. Or 8 can be written as 2 cubed, okay? So 2 cubed is 8, so this y was already there, so we write y minus 16, okay? First let me take the LCM. 16 means 2 to the power 4, okay? Now I take the LCM of 1 and 2, the LCM will be 2, okay? So 1 into 2 is 2, so 2 4s are 8, minus 1 into 2 is 2, so 2 into 1 is 2, so that 1 into x is x, okay? So equals to 0. I hope you are getting me. 16 means 2 to the power 4. 16 means 2 to the power 4. 2 8s are 16, 2 4s are 8, and 2 2s are 4, isn't it? 2 multiplied 4 times gives us 16. Now we take, so this 4 is this 4, and now we solve this, we simplify this. The LCM of 1 and 2 is 2, so this 1 into 2 gives us this 2, so 2 4s are 8, this minus sign comes here, so this 2 into 1 gives us this 2, so this 1 into x is x, okay? And in the right hand side we have 0. Now what we do is 2 to the power 3y equals to, let's take this number to the right hand side, minus 2 to the power whole thing we'll take to the right hand side, it becomes plus, okay? Minus when taken to the right hand side becomes plus. Now we cancel this, 2 1s are 2, 2 2s are 4, okay? 2 1s are 2, 2 2s are 4, and this minus 2 when goes to the right hand side becomes plus. Now 2 8s are 16, minus 2 into x is 2x, okay? Minus 2 to the power this whole thing I take to the right hand side and becomes plus. Now 2 2s are 4, 2 8s are 16, minus 2 into x is 2x. Or this 2 and this 2 same thing, bases are equal, means power should be equal. 3y equals to 16 minus 2x. Or I bring this minus 2x to the left hand side, plus 2x, minus 2x when I bring to the left hand side becomes plus 2x, plus 3y, okay, plus 3y equals to 16, okay? This is equation 2. So we have equation 1 here, and this is equation 2. Now we will solve these two equations to find the values of x and y, okay? So I want to solve this. There are various methods of solving simultaneous equations, like elimination method, substitution method, comparison method, cross multiplication method, and so on. But I will solve this equation by the method of elimination right now. So to solve simultaneous equation by the method of elimination, elimination means I eliminate either x or y, okay? Eliminate means I remove either x or y from the equation, okay? So if I want to eliminate y, the coefficient of y in both the equations should be equal. Here we have the coefficient of y as 3, and here we have the coefficient of y as 2. So with this 2 I multiply equation 2, and with this 3, the coefficient of y here is 3. The coefficient of y is 3. With this 3 I multiply the equation 1. Okay. Now when I multiply, I should multiply all the numbers right from the beginning to the end. Okay, not only this. So now our equation 1 becomes 3 5 is 15x minus 3 2 is 6y equals to 3 2 is 6. This is equation 1, isn't it? Equation 2, 2 2 is 4x plus 2 3 is 6y equals to 2 16 is 32. This is equation 2. Okay, now simply we add up, adding 1 and 2, adding minus 6y plus 6y, equal number but opposite sign, isn't it? So these two numbers can be cancelled. So plus 15x plus 4x is plus 19x, isn't it? 19x, same sign means we should add the number. So plus 15x plus 4x plus 19x equals to 32 plus 6 is 38. X equals to 38. This 19 goes to the denominator. 19 1 is 19, 19 2 is 38, isn't it? So we got the value of x as 2. Now we can find the value of y as well by putting the value of x in equation 1 either or 2. Okay, let us put the value of x in equation 1. Putting the value of x, let me do this sum here. I'll erase this. Okay, putting the value of x in equation 1. So we have equation 1 as 5x minus 2y equals to 2. 5x minus 2y equals to 2. This is equation 1, isn't it? So the value of x, we have 2. X is equals to 2. So 5 into, instead of x I write 2 minus 2y equals to 2, or 5 to is 10 minus 2y equals to 2, or minus 2y equals to 2 plus 10, I transpose to the right hand side, becomes minus 10, or minus 2y equals to plus 2 minus 10 is minus 8, isn't it? 10 minus 2 is 8. The sign of greater number comes here, so this minus and minus cancels out. Y equals to 8 upon this 2 comes down to the denominator. 2 1s are 2, 2 4s are 8, or y equals to 4, isn't it? Therefore x equals to 2 and y equals to 4. Okay, we were asked to find the values of x and y, and the values of x and y are 2 and 4. Okay, I hope you got this. Now let us do question number 7. Do question number 1 of 7. Okay, we are asked to prove this is the left hand side. Okay, this is the left hand side, and we are asked to prove this left hand side equals to 1. 1 is in the right hand side, isn't it? So let's do this. LHS equals to x to the power a upon x to the power b, x to the power a upon x to the power b, isn't it? Same base, x, and they are being divided, isn't it? So this can be written as x to the power a minus b. Okay, plus b becomes minus b. X to the power a divided by x to the power b can be written as x to the power a minus b, isn't it? So x to the power a upon x to the power b means x to the power a minus b, okay, into a plus b minus c, a plus b minus c. This into comes here. X to the power b upon x to the power c means x to the power b minus c into b plus c minus a, b plus c minus a, into x to the power c upon x to the power a means x to the power c minus a into c plus a minus b. Okay, So this is left hand side, isn't it? So we are going to use this and prove this equals to 1. Okay, so we know the formula: a plus b into a minus b equals to a square minus b square, isn't it? A plus b into a minus b equals to a square minus b square. So you can see this a minus b into a plus b. Okay, a minus b into a plus b, first we multiply, and after that a minus b into minus c. Okay, so this gives us a minus b into a plus b is a square minus b square, minus, this minus comes here, minus c into a minus b. Okay, I am multiplying this whole expression with a minus b. A minus b into a plus b, first I multiply and write here, and this minus sign comes here, and again a minus b into c is c into a minus b, into x to the power, here the same thing, a minus b into a plus b means a square minus b square. A minus b into a plus b means a square minus b square, isn't it? So a is b, a square minus b square, again this minus sign comes here, b minus c into a, that is a into b minus c. Okay, into x to the power, same thing, a minus b into a plus b, that is a square minus b square, into this minus comes here, b into c minus a, b into c minus a, isn't it? So x to the power a square minus b square minus c into a, ac or ca, you can write ca or ac as you wish. Okay, same thing. Minus into plus is minus, c into a is ac, again minus into minus is plus. Okay, c into b is bc or cb, same thing. Minus into minus is plus, c into b is bc. Okay, now since their bases are equal and there is multiplication sign in between them, we can add the powers, isn't it? So plus b square minus c square, minus into plus is minus, a into b is ab, minus into minus is plus, a into c is ac, again plus, I am adding the powers. Okay, c square minus a square minus b into plus c, minus b into c is bc, minus into minus is plus, b into a is ab. Okay, this gives us, oh, this is a square, isn't it? X to the power, so plus a square you can see here, and here you can see minus a square. So plus a square and minus a square can be cancelled. So minus b square and plus b square can be cancelled. Minus ac plus ac cancelled. Okay, plus bc and minus bc can be cancelled. Minus c square and plus c square can be cancelled. Minus ab and plus ab cancelled. Everything is cancelled, nothing is left now. So x to the power 0. Anything to the power 0 is always 1, isn't it? Except 0 to the power 0 is not 1. Other than 0, any number raised to power 0 is always 1. So this is 1 equals to RHS. So we have 1 in the right hand side, hence proved. So let's do question number 2 of 7. Okay, let's do question number 2 of 7. So in the left hand side we have these numbers, and we are asked to prove this equals to 1 in the right hand side, isn't it? So LHS equals to, first let me copy left hand side. Okay, x to the power a b minus c whole upon x to the power b a minus c divided by x to the power b upon x to the power a whole to the power c. This is what we have in the left hand side. So we are asked to use this and prove this equals to 1, isn't it? Equals to x to the power a b minus c. Now the same base, isn't it? And this number is divided or is in the denominator. So when we take this number to the denominator, the power gets subtracted, minus b into a minus c. Are you getting me? a to the power m divided by a to the power n equals to a to the power m minus n, isn't it? So x to the power this divided by x to the power this, same base x and x, same base a and a. So here we have m minus n, so here we have this minus this, isn't it? So divided by, now this power c is outside the bracket and within the bracket remains x to the power b and x to the power a. So we put this power c individually, okay? So this means x to the power bc, b into c is bc upon x to the power a into c is ac, okay? This is divide. Now x to the power a into b is ab minus, this minus comes here, a into c is ac, minus into plus is minus, b into a is ab, minus into minus is plus, b into c is bc, divided by x to the same base, isn't it? Same bit, same base. So x to the power bc minus ac, bc minus ac. So this minus ab and plus ab can be cancelled. This gives us x to the power let me write this plus number first, okay? Plus bc and minus ac divided by x to the power bc minus ac, isn't it? This plus bc I write first and then minus ac, okay? Plus 2 minus 3, this gives us minus 1, isn't it? So if I write this minus 3 first and then plus 2, same thing, this gives us minus 1. Minus 3 plus 2 minus 1. So I can change the places of the number, but I cannot change the sign, okay? bc is plus, so bc is plus, ac is minus, ac is minus. Here we have bc minus ac, bc minus ac divided by, okay? So let me continue here. So this is a to the power m divided by a to the power n, isn't it? Same base means the power gets subtracted. X to the power bc minus ac, bc minus ac minus this, isn't it? Minus bc minus ac, bc minus ac. This equals to x to the power bc minus ac minus into plus minus bc minus into minus plus ac, okay? This gives us plus bc minus ac plus ac, x to the power 0. X to the power 0 means 1, isn't it? Any number raised to power 0 is always 1 other than 0. 0 to the power 0 is not 1. So any number raised to power 0 other than 0 is always 1. This is equal to RHS, okay? 0 to the power 0 is never equal to 1, okay? This is not equal to 1. 0 to the power 0 is infinity, undefined, okay? So I hope we got this. Now let's do question number 8. Okay, let's do question number 8. So we are provided with these three conditions: a to the power x equals to b, b to the power y equals to c, and c to the power z equals to a. These are the three conditions provided to us, and we are asked to prove x, y, z equals to 1. Okay, so let's do this. Now since a to the power x equals to b, isn't it? Now if we have number like this, a equals to b, we can write squaring both sides, isn't it? Sometimes we do this, squaring both sides. So you can write a square equals to b square, isn't it? Sometimes if we have a plus c and equals to d, then also we can square both sides. Squaring both sides, what we do is a plus c whole squared equals to d squared. You can do cubing both sides also, okay? Cubing both sides means you put cube here, you put cube here, okay? What I mean to say is, if left hand side and right hand side are equal, Okay, whatever you do here in the left hand side, you must do the same thing to the right hand side. If you add a certain number in the left hand side, you must add the same number to the right hand side. If you divide certain number in the left hand side, you should divide with the same number in the right hand side as well to make the equation equal. Okay, if you add plus 2 here, you must add plus 2 here also. You cannot add plus 3 here. This equal to sign will not be valid. Okay, to make this equal to sign valid, what we do is, whatever we do in the left hand side, we must do the same thing in the right hand side. Okay, when we square, we square. When we divide, we divide. When we add, we add. When we subtract, we subtract. When we multiply in the left hand side, we must multiply in the right hand side as well. Okay, now we have a to the power x equals to b. Now you can see b to the power y, isn't it? So I put the power y to the both sides, like squaring both sides, or a to the power x whole y equals to b to the power y. I am putting power y to both sides of this equation. Okay, or this gives us a to the power x into y is xy equals to b to the power y, isn't it? We have b to the power y, so b to the power y is c. You can write c here instead of b to the power y. Okay, now what I do is, you can see c to the power z. I put the power z both sides of this equation. Okay, a to the power xy whole raised to the power z equals to c to the power z. Now I am putting the power z to both sides of this equation, or this gives us a to the power xy into z is xyz equals to c to the power z, isn't it? C to the power z means a, so c to the power z means a, isn't it? C to the power z is a. This is the given condition to us. So what I do is, a means if there is no power, we should always understand there is power 1. Okay, if there is no power, if I write 2, you must understand there is power 1. Okay, if I write 10, you must understand there is power 1. No need to write 1, but we must understand there is power 1. Unless another power is mentioned like this. This is 10 cubed. You cannot erase this cube and write 1. Okay, but if there is no power, we should understand there is power 1. Now bases are equal, a and a, so their power should be equal. Therefore x, y, z equals to 1. Hence proved x, y, z equals to 1. Okay, I hope you got this. Now let us do question number 9. Okay, now let us do question number 9. We have a to the power x equals to b to the power y equals to c to the power z. This is the given condition, and another condition is b square equals to ac. These two are the given conditions. Okay, so we are asked to prove y equals to 2xz upon x plus z. Okay, now let's do this. Since these three numbers are equal, a to the power x equals to b to the power y equals to c to the power z, what we do is, a to the power x equals to b to the power y equals to c to the power z equals to k. We suppose all these numbers are equal, isn't it? We suppose all these numbers equals to k. Okay, a to the power x equals to b to the power y equals to c to the power z equals to k. All of these are equal, isn't it? So all of this equals to k. So now since we know that if a square equals to k, okay, so what I write is, this square when taken to the right hand side becomes root under k. If a square equals to k, then this square when taken to the right hand side becomes root under k. So a equals to root k means k to the power 1 by 2, isn't it? Root under k means k to the power 1 by 2. So a to the power x equals to k. This means a equals to k to the power 1 by x. Okay, this x 1 by x, because a cubed, if a cubed is k, then you can write a equals to cube root of k. Okay, a cubed means if I take this cube to the right hand side becomes cube root of k, or a equals to cube root means k to the power 1 by 3. isn't it? So whatever be the power, that power goes to the denominator, isn't it, in the right hand side. I hope you got this. Now we have a to the power x equals to b to the power y equals to c to the power z equals to k, means all of these are equal to k. This means a to the power x equals to k, comma b to the power y equals to k, and c to the power z equals to k. Okay, or a equals to k to the power 1 by x, isn't it? B equals to k to the power 1 by y, and c equals to k to the power 1 by z. Okay, so a equals to k to the power 1 by x, b equals to k to the power 1 by y, and c equals to k to the power 1 by z. Now since the another condition is b square equals to ac, so b square equals to ac, this is the given condition to us, b square equals to ac. So what is b? B is this, k to the power 1 by y, we put the value of b here, k to the power 1 by y whole squared, okay, equals to ac. What is a? A is k to the power 1 by x, k to the power 1 by x, into a into c, ac means a into c, into what is c? C is k to the power 1 by z, k to the power 1 by z. Okay, so or now this 2 is in the numerator and 1 is in the numerator. We multiply the numbers in the numerators. Okay, 2 ones are 2, 2 to the power y, k raised to power 2 to the power y, 2 upon y, k raised to power 2 upon y equals to, here we have k and k same base and these numbers are being multiplied, means their powers will be added, isn't it? So k to the power 1 by x plus 1 by z. Okay, since the bases are same, equal, k and k, and they are being multiplied, so their powers will be added. Let me continue this sum here. So here we have k to the power 2 upon y. Okay, now here we have k and k, the same bases are equal, k and k. This means their power should be equal. So 2 upon y should be equal to 1 upon x plus 1 upon z, or 2 upon x, 2 upon y, 2 upon y, 2 upon y equals to 1 upon x plus 1 upon z, 1 upon x plus 1 upon z, isn't it? Or 2 upon y equals to, let's take the LCM of these two numbers, xz, isn't it? X into z, xz, x into z gives us xz, so z into 1, z, plus z into x gives us xz, so x into 1, x. Or let's apply invertendo here. Invertendo means the number from the denominator goes to the numerator, and from the number from the numerator goes down to the denominator. Okay, invertendo. Let me write it, invertendo. Invertendo. Invertendo means the number from the denominator goes to the numerator, and the number from the denominator comes down to the numerator, comes down to the denominator. Whatever I do in the left hand side, the same thing must be done in the right hand side as well, isn't it? So 2 upon y can be written as y upon 2, and here z plus x upon xz can be written as xz upon, so z plus x is x plus z, same thing, isn't it? Or z plus x and x plus z, same thing. Y equals to 2, we cross multiply this, 2 into xz, 2xz upon x plus z. Okay, so this is what we were asked to prove, y equals to 2xz upon x plus z, hence proved. I hope you got this. Thank you so much for watching this video. Stay tuned, stay connected. I'll upload the remaining questions in the upcoming video. Okay, thank you.